configuration, provisioning, and administration of NVMe and NVMe fabrics for larger, more dynamic environments. So next slide. So the Scalable Networking Industry Association, it's a large and complex organization. It's got 185 organizations that are a part and over 2,000 active, sometimes very active, contributing members, and over 50,000 end users and people that are taking advantage of the work. You can learn more at SNIA.org/technical. And the next slide. Then I want to point out that this is a snapshot. The work that we're talking about, the discussion today, is a snapshot of the work that's going on within SNIA. It's evolving. We're hoping to get material published and out by the end of this quarter, and there'll be more presentations to discuss the work that's going on. For more information for SNIA, you can go to the SNIA website or to the NVMe Consortium website. Next slide. So I presented several times to this body over the last few years over NVMe over fabrics, but I thought we'd do a quick refresher on NVMe over fabrics, and as a necessity, need to review a bit of NVMe. They will talk about managing NVMe and NVMe over fabric at scale, talk about the moving parts, the components, and some of the complexity, and then discuss why DMTF REDFISH, and particularly in this talk, SNIA Swordfish, will enable managing and administration of NVMe and NVMe fabrics as you scale into larger and more dynamic environments. Raj will take over at that point and go into great detail, very, very great detail about the SNIA Swordfish schema and mockups and what's going on, and then we'll wrap up. Moving on. The next slide. Please. Next slide. Hello?
Yes, I can hear you.
Next slide. Thank you. So
previous.
Oh, one more slide back. Sorry, one slide back. Well, there we are. Thank you. So this is a bit of a review. So NVMe is an industry standard solution for efficient PCIe attached non-volatile memory storage access. It enables low latency, high IOPS direct attached access to NVM storage. Well, NVMe over fabrics extends the parallelism and efficiencies of NVMe over fabrics. Currently supported are iWarp and Rocky, InfiniBand, Fiber Channel, and TCP. Really, so NVMe over fabrics builds on the base NVMe architecture with a thin encapsulation of base NVMe across fabrics. And as you can see on the right, there is an example NVMe over fabric software stack, kind of a higher level abstraction. But you can see in the middle there, the NVMe core block has the base NVMe architecture that handles how to access drives and get and service requests. Below it are the fabrics components, the pluggable architecture for, in this case, TCP and RDMA and Fiber Channel. And this is designed such as easy to add new fabrics as new fabrics come online and are more interesting and necessary in larger installations of NVMe and NVMe fabrics. But the point is, it's the same architecture regardless of the transport. You have an end-to-end mechanism for transferring NVMe commands and data structures, and abstraction on the resource side, on the NVMe or fabrics target side, for exporting NVM subsystems or fabrics. In addition, you have the capability of some access restrictions of either the NVM resources are restricted to individual initiator consumers, or they're unrestricted, so any initiator or consumer can access those remote resources. And that's a bit of a refresher. And if we go on to the next slide, we slightly deeper dive into the NVMe fabrics components. So for NVMe and NVMe fabrics, you have the components such as the subsystem, the controllers, and the namespaces. A namespace is NVM storage formatted for block access. It's really analogous to volumes in a storage array. NVMe controllers, they provide access paths between host consumers, initiators, and namespaces. And the subsystems are storage arrays. They can include several NVMe controllers, several namespaces, non-volatile memory storage medium, and the interface between controller and non-volatile memory itself. And then NVMe fabrics adds a bit to that. You have the initiator, and you have to be able to administrate and configure and provision initiators for resources that they can have access to. And you also have to administrate all the fabrics that go between initiators and the target resources that exist somewhere. In order to do this administration and configuration and provisioning, you have set configuration and get configuration management operations. that administrators can use to figure out what resources are available, how to access them, what they look like, and you have health status requests and commands. In addition, you have the capability to reset various components to certain base states. So this is somewhat complex, and as you get larger installations, larger scale, larger numbers of fabrics, as resources come and go, as models change, as usage models change, this becomes very complex. And that's why we're introducing the Swordfish and REDFISH models. And if we go to the next slide, which is really the introduction to DMTF, REDFISH, and SNIA Swordfish. Well, REDFISH is really an infrastructure management standard. It's a successor to IPMI for extended management scope. It focuses on management of scale-out commodity servers using RESTful APIs, OData, and the get, put, and post HTTP operations. The main categories for REDFISH server management are systems, managers, and chassis. It manages servers, CPUs, memories, devices. It manages the BMCs, the enclosures, and it manages the chassis, the sheet metal, really, the racks, the enclosures, the blades, that sort of thing. And REDFISH is expanding. It's expanding to cover more than this, but data center infrastructure, fabrics, network management, and other things. So Swordfish builds on REDFISH. It builds on REDFISH to enable more complex storage management and ecosystem standards. It uses the same REDFISH schemas and extends them. And its focus is storage management, building to encompass, as we're going to talk about, as Raj is going to talk about very soon, NVMe and NVMe-oF fabrics. And so what this is going to do is enable, as I said, configuration at scale, management at scale of NVMe and NVMe-oF fabrics. And then Raj will talk on the same line here. You don't have to mute it so she can speak next.
Next slide. Yeah, hello everybody. So, the slide, the picture on the slide we are seeing is a storage model with Swordfish, and like we can see that there are some words with saying REDFISH, and then there are a lot of storage components here. So, like Phil mentioned, Swordfish builds on REDFISH. So this is how the various resources in both REDFISH and Swordfish are laid out so that you can do management of these resources. Like we see, we have different colored blocks. Let me tell you what are those. The blue and the purple blocks are nothing but the resource collections. Those are like a set of resources of a similar kind. And the gray blocks are nothing but the singleton resources. So the model starts from left. So like it starts from REDFISH here. So we can see that we have, in the black boxes, we have the links for URLs. So it starts from REDFISH. So the top block says it is REDFISH v1 systems. And the systems has computer system which consists of storage. And like Phil mentioned, REDFISH manages systems, chassis, and BMCs. The BMCs are not shown on this diagram. So let's start from the system. So within systems, we have a computer system, and there can be an ID for that system. So this is just an example, so we don't have a specific IDs here. So the computer system has got storage collection, and we have a storage S1 within that collection. And we can see that there are like complex storage constructs like storage pools, storage groups, consistency groups, endpoints, etc. defined here. And we can also see that there are like so many lines going on from crisscrossing multiple blocks here, which shows that how these complex storage constructs are built. Like for example, the storage pools are built from multiple drives here. The volumes can consist of consistency groups, and the file systems can be built with different volumes. So we can also see that, again, coming back to REDFISH chassis, we have a chassis collection, and then we see that there are like a couple of drives sitting in those chassis. This is how the physical drives are represented. And we can also see that the same drives are used to carve out different storage elements. So next slide. So now that we had seen a generic kind of a generic storage model with Swordfish, let us see how NVMe and NVMe-oF fabrics resources can be laid out in that kind of a model so that they can be managed in a large-scale infrastructure. So it is the first time ever DMTF, REDFISH, and SNIA, Swordfish, and NVMe have a connection, and they are coming out together to build this kind of a management model. So the way to look at the diagram on this slide is we have a mapping diagram between NVMe and Swordfish. So to understand how NVMe and NVMe over Fabric resources are managed with Swordfish, we will use 3 steps. First, we will see what are the various resources that are in NVMe and NVMe over Fabrics, and we will see how they are mapped into REDFISH and Swordfish world, like the way it is shown on this diagram. And then we will see the model, like the way we had seen in the previous slide, the model which can hold REDFISH, that holds REDFISH, Swordfish elements, and including NVMe and NVMe over Fabric resources. And then we will see parts of the schema mockups that we are implementing to see how these resources are represented into the schemas. So in this diagram, it is divided into 2 parts. The right-hand side of that blue vertical line is the NVMe device model. It is the local physical NVMe device, and the left side is the Swordfish, REDFISH elements. And the green arrows show the mapping, 1:1 mapping between both worlds, and the purple and the blue lines show the relationship between the components in each of the models. Like we can see, this is a simple NVMe drive, which consists of 1 I/O controller and 1 namespace, and it does not have any endurance group or sets in this model. So in this configuration, so it's a simple configuration. So we see that namespaces are mapped to the volumes in Swordfish, and I/O controllers are mapped to controllers, and subsystems are mapped to systems. We can also see there is a link between the drive in the Swordfish to the volumes, showing that the volume is carved out of that drive. Next slide, please. So yeah, this is the Swordfish model, which incorporates NVMe and NVMe resources. Like we see again, the model starts with REDFISH. We have a REDFISH V1 systems, and we have it is a collection, and we have a computer system singleton resource called sys1, and which has a storage collection, and NVMe subsystem is the storage under the storage collection. So that is a NVMe subsystem. Like we had seen in the previous slide, this NVMe subsystem has got 1 controller and 1 volume, and those are represented by the blocks over there. The volume is called a simple namespace, which sits under the volume collection under the simplest NVMe subsystem. And we see that there is a NVMe I/O controller that is under the controller collection, and again that is also sitting under simplest NVMe SSD subsystem. Now coming to chassis, under the chassis collection we have the drive collection, and we see that there is a simplest NVMe SSD drive that is sitting in this drive collection. And we also see that there is a link going on from simplest NVMe SSD drive to the simple namespace, which shows that this namespace is being carved out of this drive. And we also see that there is a link from NVMe I/O controller going into the simple namespace, which tells that the namespace is like this controller is the interface for accessing this particular namespace. Next slide, please. Yeah, so this slide shows the snippets of the mockup that we are implementing in SNIA, SSM technical working group. So what are mockups? Mockups are nothing but state in time of a state of a particular system. So this has been adopted by both REDFISH and Swordfish. What we do is we implement the mockup and then tweak and enhance the mockup so that it can cater to your exact use case. So to begin with, the top highlighted block on the right side shows that this is starting with the computer system called as sys1, and we can see that is highlighted by the first block. And this system has got a storage, and that is highlighted by the second block here, and which shows the link for that storage, which is like REDFISH V1 systems, sys1 and storage. And we can also see that there is a link to the simplest NVMe SSD drive, which is sitting in the chassis. So these are nothing but the JSON schema files. So schemas can be defined in either in JSON format or XML format. Both are being implemented. So this one is the JSON format. So moving on to next slide. So continuing on to the mockups. So we have seen that system 1 has got a storage, and like the left side of the slide shows that this system has got a storage collection, and the path for that is sys1 storage and simplest NVMe SSD, that is the NVM subsystem. And on the right side, you can see that the subsystem is identified by NQN, and that is how we define the identifier for this subsystem. So NQNs are nothing but NVMe qualified names. Those are unique names to identify either NVMe entities like host or targets. And we also see that this subsystem has got one controller and one volume, and those are represented by those links with the OData IDs, which is highlighted by the blue box on the right side. And the link for this subsystem is on the top of that right side block, which is like REDFISH V1 systems, blah, 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 simplest NVMe SSD. Please move on to next slide. So continuing on to this markup, in this simplest NVMe SSD model, we have like the namespace. Now let's see how namespaces are defined. The link where the namespace lies is shown by the highlighted first block. And we have seen that this namespace sits under the volume collection under the simplest NVMe SSD. And we can also see that we have defined the capacity for this namespace. And there are a bunch of properties that are being defined for this namespace, like whether thin provisioning is supported or not, whether atomic transactions are supported or not, etc. So this is how namespaces could be defined, and we can do like HTTP operations on these resources to either set or get the resources. Like for example, if you want to know what is this namespace all about, then you can do an HTTP GET operation, and you can, the example is shown at the bottom of the slide, like you can do a GET with the whole path for this namespace with the namespace ID, and then you'll be able to access information about this namespace. Next slide, please. Then now moving on to controllers. So we have seen how namespaces were defined, and let's see how controllers are defined. So again, we see that at the top we have a OData ID which shows the path where this controller sits. So we have seen that this is also part of NVMe subsystem, and it is under the controller collection. This controller is called as NVMe-IO controller, and that is specified by the ID. And we have a bunch of other things like model, manufacturer, etc. for this one. So there are other controller properties that are being defined. I could not fit in this slide, so I put them in the next slide. So let's go to the next slide. So like I've shown in this slide, there are a bunch of NVMe controller properties that could be defined. So the properties like namespace granularity feature, or whether endurance groups are supported or not, whether sets are supported or not, etc., could be defined under NVMe controller properties. We can also see that there is a link attached, link saying that there is an attached volume for this one, and there is a path for that volume. So this shows that this particular volume can be accessed with this controller. So moving on to next slide. So this slide shows, again, this is another configuration of NVMe. That is a local PCIe attached NVMe. But this has got a couple of other constructs like endurance groups and sets. And on the right-hand side, we can see that this NVMe device model has got multiple I/O controllers, multiple endurance groups, and sets. And we have the corresponding redfish, swordfish elements on the left side of the blue line. So I'm just showing this as an example so that we can build NVMe or Fabrics subsystem on top of this. This is another local PCI attached model, like I said. So move on to next slide. Yes, so NVMe or Fabrics model is a very complex model. So the way to look at this diagram is, let's start focusing on the right side of that blue line. And we can see that there is a portion of the slide at the center which is kind of grayed out, and that is nothing but the device model that I showed in the previous slide. So we can see that on the right side of the grayed out portion, you can see that that a local NVMe device has got multiple I/O controllers, it has got endurance groups, and it has got sets. And there are a bunch of blocks that are orange blocks. Those are nothing but NVMe or Fabrics resources. So the way to look at is, if you see the miniature diagram on the right corner, you can see that an NVMe over Fabrics subsystem, which is the dark blue box at the center of that, is constructed using the underlying resources available. So similarly, we have the orange blocks. Those are all NVMe over Fabrics subsystem, which will have namespaces, controllers, ports, and the allowed hosts. And those are all constructed using the underlying resources. For example, a logical NVMe over Fabrics namespace is constructed using some of the underlying namespaces. So basically, like Phil said, NVMe over Fabrics subsystem is an abstraction over the underlying NVMe so that it can be exported and the remote NVMe host or initiator can access it. So we can see that we have the corresponding mappings into REDFISH and Swordfish world. So we see that there is also a mapping for these logical NVMe or Fabric resources. We have the corresponding REDFISH, Swordfish elements. So for example, the subsystems are mapped, the logical NVMe subsystems are mapped to storage, the logical I/O controllers are mapped to controllers in REDFISH, Swordfish, and the logical ports are mapped to the Fabrics endpoints. So we will, in the next slides, I'll show you how some of these are implemented, and some parts of the markups. So the way to look at is just to have this mapping, and then those the end, rightmost end and the leftmost end portions are nothing but NVMe or Fabric subsystems. Next slide, please. So this slide shows the a snippet of the markup for NVMe or Fabric subsystem, and on the left we can see that the central block is NVMe or Fabric subsystem, which is constructed from the underlying resources, and the right side shows the markup snippet for it. And we can see that there is also a similar identifier for a subsystem here, which is represented by an NQN, and this NVMe-oF subsystem holds a controller and a volume, and the link for those controllers and volumes are shown by those highlighted blue blocks. So next slide. Yeah, and so NVMe or Fabric subsystem has got ports defined, which are defined by the endpoints, and the right side shows the implementation in the snippet for this endpoint schema, and we can see that there are like transport details that are defined, which defines IP addresses, transport protocols, and port details, etc. And this is how a Fabric endpoint is defined. So there are like other definitions for all the other resources for NVMe or Fabrics. I could not accommodate all of the details, and it is very huge. So you have to visit, you have to go to swordfishmarkups.com, or you have to visit SNIA SSM working group to find out how these schemas are defined. So next slide, please. So to summarize, the schema modeling is work in progress. So we have mockups for a simple NVMe with endurance groups and sets, and JBoss and fabrics attached arrays. So various advanced features like NVMe power profiles properties will be added in the future. So REDFISH and Swordfish are planning to release a draft that incorporates NVMe and NVMe-oF fabrics management in June of 2020. So those are available for public review then, and please go to those that link of swordfishmockups.com and SSM working group to ensure that schemas are defined sufficiently and they can cater to your use cases. Or you can also mock up your use cases and submit it to the forum. There are various tools available to verify the schemas as well. So you can participate or just get information and contribute to SNIA SSM technical working group, and the link for that is presented at the bottom of the slide. With this, I think I'm done with my presentation, and we are open for questions. Thank you.
Thank you, Rajalaxmi, and thank you, Phil. We have a guest presenter along with these guys coming from Broadcom. Richelle is storage management software architect at Broadcom, where she defines storage management integration solutions and standard strategies for their DCG group or data center storage group. And she's also on the SNIA board of directors. Richelle has been engaged with industry initiatives quite a bit, such as SNIA, DMTF, and the EU Stand ICT initiative for many years. So any questions at this time from the audience for either Richelle or the two speakers? Richelle, any remarks you would like to add?
Just to follow up on the availability that Raj was just pointing out, the swordfishmockups.com site with all the mockups that she just referenced went live this weekend. So those are all available. Please check that out. The schema and the work in progress documentation should be posted to the SNIA website tomorrow. And it looks, I just checked, the REDFISH portion of that was posted today. So all of this stuff is very timely, as Phil and Raj both pointed out. This is all work in progress right now. Everything has been posted as work in progress. We are looking for active feedback right now and are looking for to lock this down as technical specifications in about 3 months. So we are looking for a lot of feedback.
Yeah, thank you, Richelle. All right, so I guess I will take any questions offline, and I know how to catch hold of Raj or Phil, so I'll make sure the questions go to them. Anything I get offline. So thank you, all of you, 3 of you, for being here, spending the time with the OFA community. I hope you get some useful feedback from us. Thank you.